Kirti, you would have received an email when you registered. That email contains the document link with the steps to activate credits and creating a project. Please refer that. Okay, you would have received the email from Code Vipassana Google Events email. Go ahead and open that and you will find the details. All right, so let's get started. Open the code lab. If you haven't activated the credits yet, or if you feel that you need more time to create project and everything, just pay attention to the lab. Once the session is complete, you will get a recording of this and the doc that contains the steps to activate your billing account, to create a project, and to verify if you have billing added, which is not needed. You don't have to verify. It will be added by default once you create billing account. So all those details will be sent to you, so you can watch the recording and do it at your own time as well. So you can follow. Those who are unable to create a project yet can just follow the code lab as I'm going through. Open the code lab though, so you know which step I'm talking about, and try to visualize that in your GCP console parallelly. Those who have already created the projects and are all set to go, please follow along, because if you complete all the hands-on during the session timing itself, you don't have to spend extra time to complete it. So you can easily submit the results as soon as you complete. So yeah, suit yourself. So let's get started. What we're going to discuss today, like I said before, is building a patent search app with this code lab. Is Spanner, Vector Search, and Gemini Pro. So I'm going to ping the link to code lab number 1, and I'm going to pin this again, just in case. And I'm also going to pin the link to code lab number 2, the AlloyDB one. You don't have to necessarily open the AlloyDB one right away. It's just something for you to. Oh, I have the same link repeatedly. Okay, the AlloyDB one. Let me ping you in 1 second. It's there in the registration. You would have also received it in email. So yeah, here you go. That's the second link in the meeting chat. I'm trying to pin this. 1 second. And there we go. I've pinned both of it. We'll go through the Spanner one now. All right. So make sure you have the code lab open so that you know which step we are going through at the moment. So if I ask you to copy paste, it's easy for you to reference. So we are going to build a patent search or literature search application, because it could be any literature. It doesn't have to just be patent data. In this case, since we are going to use a patent data set, it's called, I've named the code lab as Patent Search Code Lab. Right? I already explained what our objective is and what exactly we're going to do. If it was not clear, you can see my screen right now. You can see a small flow diagram, very high level flow diagram that says exactly the steps that I explained to you before, which is we'll have patents data stored in our database. In this case, it is Spanner. And then we'll have LLM-driven keyword summary extraction. So we will extract summary and keywords from this using Gemini 1.0 Pro. And then we'll convert the summary into embeddings. Why are we doing this? Because we want to do vector search, and vector search can be done in a higher scale and also at a higher speed using embeddings. Embeddings are numerical representation of any data. In this case, we are going to use text embeddings model because it converts text to embeddings. So when we say embeddings, you could think of it as an array of floats. You will see what it looks like, right? So that's why we're using embeddings. And then we'll perform real-time vector search on user data against the patent data set for which we have collected the embeddings and stored in the database. Or in real time also, you can use a select query and check it, and that's what we are going to do. So remember, since we are going to perform real-time user data search, user search query will also be converted into embeddings. So you will be performing embeddings to embeddings vector search. That's all we are going to do. And for this, as I said before, we are going to do in-place LLM and in-place vector search, which means within the database itself, within the scope of database itself, without writing additional coding or without doing extra additional lines of programming language of coding as in addition to just writing SQL queries. Instead of doing that, you will only use SQL queries to both convert it into embeddings and also to perform vector search, and also to use Gemini to convert your abstract information into summarized keywords. All right, so that's exactly what we're going to do, only using SQL queries. We'll use some DDLs, which is data definition language, here and there, because we need to create the table. We need to use some DMLs, which is insert statements, to insert the data. And then we'll have to do create model statements, so you can access the model that is available in Vertex AI from within the scope of Spanner. So you will have to do some DDLs and DMLs here and there, but ultimately a simple select query is what you will use, and ml.predict is the kind of syntax that you'll be using in the query to get the results for the whole thing, for this overview that you're seeing right here. All right, so we have already activated the credits. We have already created the project. Now, one last thing that you need to do is activate or enable Spanner API and activate Cloud Shell Terminal. All right, so these are two things we'll be doing. So Cloud Shell Terminal is also optional in this case, because we are only going to directly use there'll be one step where we'll be creating Spanner instance here using a gcloud command. So it's better to have the Cloud Shell Terminal activated. So let's see how to do this. All right, those who have everything ready and set up the project, I hope everyone is was able to utilize this time so far to activate the credits, create project, and create billing account, and everyone is able to see the screen that you're seeing right now. Now, in the search bar, go ahead and search for Spanner. It should say under products and pages, you should see Spanner. Go ahead and click that. If it's the first time you're accessing it, it will be asking you to enable Spanner API. It's a straightforward thing. Just go ahead and click enable Spanner API and it'll be enabled. If not, there's another way to enable it, but this is easier. So go ahead and do this. Show of thumbs, how many of you are able to complete till here? Perfect. Okay. So what we're going to do, those who have this page open, Spanner already open, and the API enabled, go ahead and click create instance, because what we want to do is create Spanner instance, create database, and insert data, right? Because that's typically what you do with creating database. Now, there are multiple ways to do this. You can do this through console. You can do this through Cloud Shell Terminal using gcloud commands. And you can programmatically do this with any client library like Java library or Python library, or you can use some of these commands in your Terraform scripts if you're productionizing this. But right now, we will do it through console. All right, provide an instance name. Refer to the code lab. Just check what name I have recommended. The reason I'm saying that is sometimes when you copy paste, you want to stick to what name I've suggested there in the code lab so that you don't have to replace everything. All right, so the name that I've suggested in the code lab is Spanner-Vertex. So go ahead and copy that. This is in step 3 of the code lab. Prepare your Spanner database, create a Spanner instance. See, it shows Spanner-Vertex. So copy that and paste that in the instance name. And instance ID shows Spanner-Vertex. Click. That's fine. Don't have to change anything. Click continue. It says regional. Select a configuration. Click that and choose US Central 1. Type in the filter, start typing US hyphen Central 1 should be the Iowa option should be number 1 in my case, in your case too. So go ahead and click continue. It will show by default nodes and allocated 1 in quantity, manually allocated 1 in quantity. Let it be as it is. Don't change anything. Go ahead and click create. Now, in the code lab, if you notice, I have a slightly different version of the step, because instead of doing it through console, you can also do it through Cloud Shell Terminal, right? Those who have done it through console right now, who have followed me along, don't have to do this step. Those who have not done this and you're waiting to do the step per the code lab, it's straightforward. Just this is an equivalent Cloud Shell gcloud command to do the same thing. Basically, you're creating an instance with the same name, with the same configuration of region US Central 1, description also Spanner-Vertex, and nodes 1. Same thing. You can copy this and run it from your Cloud Shell terminal. I'll show you where Cloud Shell terminal is. Meanwhile, my instance is already created, but still I'm just going to show you how to activate Cloud Shell terminal and run this command. So if you see on the Google Cloud Console, right next to the search bar, you see this activate cloud shell icon, right? The square, and inside the square you see a right angle bracket followed by a small underscore. Go ahead and click that. That will activate. That will open a small terminal window in the bottom of the screen. It should say Cloud Shell Terminal. Once it'll take a few seconds. It'll ask you to enable the API if this is the first time you're doing that. Go ahead and click that, and this page will load in a bit, and it will show you a terminal. It's just like any terminal that you will use to interact with the operating system. In this case, you will be interacting with Google Cloud Services, right, using gcloud commands, or what we call as Cloud Shell commands. All right. So as you can see, my terminal has loaded. So once you activate this Cloud Shell, it will give you two things. One is terminal, and the other one is editor. Basically space and compute, right? Memory and compute. Why? Because you want to store storage and compute. Because you want to write code in something that looks very similar to a VS Code editor. We also call that Cloud Shell editor. If you click Open Editor, you can see that. Don't click that now. It's not required. We are not going to write any code or store any file, right? So don't have to open it, but when you at your own time, feel free to play around with what editor looks like, and the terminal to run commands so you can interact with Google Cloud Services. All right. So as you can see here, if I paste this command that I copy from my code lab, I will be able to run it from my Cloud Shell terminal. I'm not going to run it right now because my instance is already created, but this was just to show you how to do the same thing from Cloud Shell terminal. I'm going to close this because I don't want to run this right now because my instance is already created. And for those who have already created the instance, please confirm that you're able to see a screen that's very similar to this by showing thumbs in the meeting. Perfect. If you have issues creating the instance, please use the chat to ask your questions. So let me just quickly walk through the step overall overview one more time. I'm not going to do the step hands-on because my instance is already created, but I'm going to show you what you would have seen is something like this, right? You will be in cloud.console.google.com, and on the search bar, you would have searched for Spanner. You will see Spanner under products and pages. Click that. For first-time users of Spanner, it will ask you to enable API in Google Cloud under the project. You mean? I mean, if this is the first time you're using Spanner in this project, right, that you just created, it'll ask you to enable API. Go ahead and enable it. And once you enable it, this is the screen you will see. What you're seeing right now. It'll say, it'll list the instance if you already created it. If you have not created any instance, you'll see this list blank or empty, and you'll see a create instance button. Go ahead and click that button. It'll give you option to enter an instance name. You get the instance name from the code lab, which is spanner-vertex, or whatever it is in the code lab. And then the same will be copied over to the instance ID. Click continue. And then since I already have it saying, it's showing error message. Now I changed it. Now click next, and under region, choose US-Central 1. And once you choose that, go ahead and click continue. Leave the node selection to 1 by default, whatever is showing. Don't change anything, and click create. That's it. In a few seconds, your node instance will be created. And this is what your page would look like. All right. So once the instance is created, what we have to do now is create database. So how will we create database? Just scroll the default overview page of Spanner down a little bit, and you'll see databases section. Click the create database button. Now go to the code lab, see what name for database is suggested. The name for database is suggested as patents. In the same step, we are still in step 3. It says patents. So that is the name of the database. So now, if you are in the same instance, not a problem. Just scroll down and click create a database. If you accidentally clicked outside of it and came to the Spanner homepage, what you have to do is just refresh. Okay, because the project name is not selected. If you're getting a similar error message, it's probably because the project name here in the dropdown was not selected. So make sure each time you navigate between stuff, if the project is accidentally unselected, it will not list anything. So make sure the dropdown is showing your current active project. right? Make sure it is selected from the drop down. This is what you do. I have selected mine. Now my instances are being listed. So the instance which I just created is spanner-vertex. So I'm opening that. All right. And now I'll scroll down in the overview page and then I'll click create database. And like I said, the name of the database is patents. PATENTS, patents. That's what I've mentioned in the code lab. Now go back to the code lab, same step, step 3. If you see the DDL for table has been listed here in the bottom of step 3 of the code lab. Create table patents underscore data. Copy that DDL. DDL means data definition language, and it defines the schema of the table that we are creating right now to store the patents data. Right? So where will you paste this? Scroll down right below the section where you provided database name. It'll say database dialect. Leave it at Google Standard SQL. Don't change anything. Right below that, you see DDL templates under define your schema section. Paste the name of the, paste the syntax right there, the DDL statement right there. You don't have to change anything. What we are basically doing is we are creating a table called patents underscore data with 7 fields or 8 fields. So what are the fields? We have ID, type, number, country, date, abstract, title, kind, number of claims, file name, withdrawn. So these are all fields of related to patent, the data that we are storing. So interesting thing about the data, where did we get the patents data from? I'll tell you that in a bit. Hold that thought and click create button. It'll take a few seconds. Show of hands, how many of you were able to successfully create the table? Show of hands meaning thumbs up, sorry. Don't raise your hand, please. Just show of thumbs, how many of you were able to successfully complete this step? Sai, you're getting that error because you've copied only a portion of the create DDL. If reactions are muted, reactions are muted, okay. Yeah, it is unmuted now. Please go ahead and that's probably because somebody would have sent crabs. Please don't send crabs. I just said don't send crabs. Don't make me sound like your professors, please. All right. So those who are having issues here or questions here, please use the chat. Our amazing leads are there to help you out with the questions. What's wrong with the crabs? Some people don't like it. That's what's wrong with crabs. Not to eat, I mean, just generally to look at it when you're actually working on something really seriously. All right, so what happened here? Database created. So there we go. My database is created and my table is created. There we go. Successfully created. I'm seeing patents data. That is a table under the database, which is patents. All right, so we've all completed this step. Go ahead and click on the left side navigation menu, right below overview under the database section. You should see Spanner Studio. Go ahead and click Spanner Studio. This is where we are going to write queries. Show of thumbs, how many of you were able to get the Spanner Studio open? So just go to, so once your database is successfully created with the table DDL, right? You will click Spanner Studio from the navigation menu. That's it. We have landed in Spanner Studio. That's all. We are doing nothing else right now. We're just clicking on Spanner Studio. Yes, we will go over the table in a bit. So once you open Spanner Studio, between navigation menu and the query editor, you will see the Explorer pane. In the Explorer pane, you will see schema, and under schema, you will see default, and under default, you'll see tables, views, models, so on and so forth. And under tables, you will see patents underscore data. This is the table we just created. Expand that table and see what columns you have right there. As you can see right here, we have 11 columns, but there is nothing. If you do select star from patents underscore data, just type this query. Here in Spanner, you will actually see nothing, no data, because we've only created the schema. We haven't inserted any records, right? So ID is the ID of the patent, type is a type of patent. I'll explain it with the data. So now let's go to the data section. Like, we have to insert some data in it for you to go through this. Somebody has their microphone on. Reddy Gopal Krishna, can you please mute? All right, thanks. Um, right, so let's go to the data section, go to the code lab, go to step 4, which says load patent data into the database. Now, where did I get this data from? So, Google Cloud's data warehouse tool or database or analytics tool, whatever you want to call it, we have BigQuery, the data warehouse, and a very popular analytics data warehouse and database as well. So BigQuery offers some public data sets that are available as part of it, which you can use for prototyping or for non-commercial purposes, for validating your use cases, or for just trying out some of your demo applications, or build actually before productionizing your data or productionizing your application. You will see how it responds to the use case that you want to build, right? So you can use these public data sets for that purpose. There are data sets from across different industries and from different use cases and different areas. So feel free to browse through the content in public data sets. You will find a lot of use cases. Sometimes when you're participating in hackathons or when you're trying to build something specifically related to your industry, you will not know where to get data from. Feel free to explore BigQuery's public data sets and search for that in the search bar in BigQuery. We are not going to go there right now, but do it at your own time. You will get a lot of ideas. Sometimes when I don't know where to start, I'll just go search the data sets in BigQuery and then kickstart my idea from there. So it's a really interesting thing to do. So anyway, long story short, I took this patents data from that particular data set, which is BigQuery's public data sets. And the name of the data set is called, as you can see in the step 4 of the code lab, which is Google Patents Public Data Sets. So this is the data set I've used for this use case. How I've taken a few records from there and I've created this insert SQL and saved it in a GitHub repository. So right click on the insert into patents data.sql and open this repository in your tab in your browser right next to the code lab. All right. So I'm able to see this in my repo. You're seeing all the insert queries that's available as part of this table. Now, don't copy all of it. We are just for demo purposes, and since we are all in the call, we want to finish it as soon as we can. So just copy the top 10 from there. All right. Just copy top 10 insert statements or 20. That's it. That's enough. Just copy that, right? Copy the top 10 insert statements and go to your tab where you have Spanner Studio open. Paste the insert statement over here. All right. The 10 insert statements and then click run. While it's running the insert statements for the 10 rows, I'll explain what the data looks like. So we have ID of the patent. We have the type of patent like utility, design, so on and so forth. Number, the patent number, because these are all issued patents already. Country, the country where the patent is issued. Date on which the patent is issued. Abstract of the patent itself. The entire abstract of the patent itself is listed here. The title of the patent, the kind of patent. It's again some text, I think. Oh, no, it's not text. It's some code like B2 or something like that. And then number of claims on the patent itself, and then the file name related to it, and withdrawn, whether it's withdrawn or not. It's like a Boolean value that's there. That's it, 10 rows. And these are the columns we just discussed. So this is the data that we are dealing with. What we are going to do right here is we'll summarize this abstract information using Gemini model, which is available in Google Cloud's Vertex AI. But we will not navigate to that. We'll directly use SQL queries to get the summary of this abstract field from within the database itself. And then what we'll do is, on the summarized abstract, we'll apply Embeddings API and convert that into embeddings, and then perform vector search with any text that you as a user want to search and find nearest neighbors for. All right, so this is what we're going to do. I hope it explains the data that we're going to deal with right here. All my 10 records are inserted. So let me write a select query, select star from patents underscore data, and confirm if all the records are inserted or not. Yes, so I have 10 records inserted. Make sure you're able to see this as well. Show of thumbs, how many of you are able to successfully complete the step? Okay, so data is inserted. So all we have done is we have gone to step 4, right click on the repository link which is available, which is insert into patentsdata.sql, because that is where the insert scripts are. So click that link and get your GitHub repository file open, copy 10 or 20 insert statements from there, and go to Spanner Studio, run the 10 or 20 insert statements. That's it. And run the select star from query to make sure the records are actually inserted. All right, so step 4 is done successfully. Good job. Move on to step 5, which is creating a remote model for Gemini 1.0 Pro. Now, why do we need this? Because we want Spanner to talk to the Gemini model, which is Gemini 1.0 Pro. You can also use other models that are made available for use or consumption by Spanner inherently. Right now, we will use Gemini 1.0 Pro, that is in Vertex AI, but we'll use it inherently from within Spanner Studio query itself. But for that, in order to write that query, we first want to make sure that remote model is created, because Spanner needs to be able to access this as a model, or just like you would write a stored procedure call, right? So something similar to that, we are going to create a remote model. So go to step 5 of the code lab and copy the create model DDL. Copy that. So I'll explain what this is doing. Copy this first. I have pinged in the chat as well. Go to the Spanner Studio. Okay. Paste this DDL. Create model. Name of the model, Gemini underscore pro underscore model. It can be anything you want, but go with the flow. Leave it as it is. Input. So the input to this model is a prompt, because that's how Gemini works, right? You will ask the model to do something. Prompt is basically prompting it to do something. So the string that tells the model what to do. And output is the content. Whatever the model is spitting out, that is the content for us. Remote options, endpoint. So the endpoint link, it has to stay as it is, except for the your project ID within double angle brackets. That needs to be replaced with your project ID. So where will you find your project ID? Remember, on the top left corner, you have a project name which you just created. Click that. It will show the select a project pop-up. Right against your project name, you will have the project ID. The name that is displayed there might not be same as your project ID. So click that and copy the actual project ID, because otherwise it might not recognize your project. And replace the whole section, starting from the double angle brackets to closing angle brackets, paste it there for project ID, right? So that's about it. You should be able to see that in my screen as well, right? So this is what I replaced, your project ID with the angle brackets, with my project ID. Nothing else changes. Just go ahead and click run. It should take a few seconds and the model is completed. Model creation is completed. Show of thumbs only if you got to the step. Very good. Okay, so remember I said we are using Gemini for abstracting the abstract, which means summarizing the abstract. Now we are going to use embeddings model. That is the next step, right? We haven't done anything. We have only exposed the model as a remote model so far. The next step is expose the text embeddings model as well as a remote model. Why? Because that is the second step, right? Once you summarize the abstract, you will have to convert it into a numerical format. For that, we need embeddings model also from Vertex AI. That also comes under generative AI, right? So now what we'll do is go to step 6 of the code lab, copy the create model command DDL from step 6 of the code lab. I'll paste this here in the chat as well. Now, once you copy that, go to your Spanner Studio, open another editor tab or replace the existing editor tab. You don't need that create model command from the previous tab again anymore, but I just opened a new tab. Do whatever you feel like. Now, what this one is doing is create model. This is another model, remote model I'm creating called text underscore embeddings. Again, this can be anything you want, but I'm going to go with the flow of the code lab. And then what we have is embeddings. So the input to this is content, right? So what is this content? If you remember, the output from the Gemini model is content. So that is the input to this text embeddings model. And what is the output of the embeddings model? Embeddings, because you want to convert your content into embeddings. So that is what we are outputting here. So this is the output listed right here. Remote options. Again, the endpoint has the endpoint to the model. Repeat the same step there that you did in the previous model. Just replace your project ID, including the angle brackets, with your project ID, which you copied from the top left corner the last time. If you may remember it, do it. Otherwise, just click that, copy your project ID all over again, and paste that. All right. So once you're done with it, you're all set. Go ahead and run this create model DDL as well. It'll take a few seconds. And there we go. The update is complete. So the model that I'm using right here is text embedding gecko. The model that I used before is Gemini-Pro. This is for converting abstracts into summarized keywords and other things. And text embedding gecko is to convert the summarized keywords into embeddings. All right, go to the code lab, moving on to step 7. Now that all of these things are ready, all that is left for us to do is create generative insights from patent abstracts, right? So we have to do that. Before that, show of thumbs, how many of you were able to successfully complete till here? All right. Now, before I go into actual generating insights and doing a vector search, let me tell you what vector search means. I've already explained this, but just to give um, give an overview so that you're aware of why we are doing what we're doing, right? Go back to Spanner Studio and stop sending grabs. Go back to Spanner Studio. Look at the data one more time, right? You can just look at my screen as well, not a problem. So as you can see right here, my select star from patents data. Look at this. So this has, like I said, all these columns, and go to the abstract column and see what it looks like. Expand this row. You see what the abstract looks like? It looks like this. Now, if I want to summarize this, it will probably be summarized into a format, which you will see shortly. And then that will also still be text. Let's say this is the abstracted, summarized abstract. It is not, but just assume. Now what I'm going to do is convert this into embeddings, which is a vector format, or what we call as the array of floats format. Now, once it's converted, I want to do nearest neighbor search in real time, right? I have all these, say, million records of history, historical patent data, but I want to search. I have this brilliant idea where I have a new strategy for generating images or recording voice and converting that into images instead of words, right? Now, this is my idea. I want to submit a utility patent, right? But before submitting, I want to do some literature search to see if anyone has already worked on this area. Now, what I'll do, typically in the past, what you would have typically done is do a keyword search of mics, text to language translation, or audio to text conversion, or audio to image conversion, or stuff like that, and you will search. But now what I'm telling you is you can actually type in the words that I exactly used to explain my idea. You can type like that, and you can make the solution relate to the nearest neighbors to that idea and bring in the results for you, if there is any related to that, right? So that is what we are going to do. And why we are doing vector search for that is, this is a small data set, right? You use 10 records out of whatever is available, but let's assume your data set is big. You want to be able to search fast at a larger scale, and you will want to be able to search context based and not just keyword based or elastic search based, which is like basically spanning across multiple records and columns of your data. And you will want to include augmented information as well as context, right? Or in some cases, you may want to convert images into embeddings and compare text embeddings and image embeddings, and then compare that with the context. There are so many applications of using vector search, right? So this is the reason we are using vector search, so that it makes the search fast and scalable. And for that, we need this to be in the form of low-level format, which is in the numerical or vector or float format, array of floats format, instead of the actual text itself, because processing that and searching that in the NLP era, I'm not saying NLP is gone now, we still use NLP, but in the past, it would have been a lengthier process without vector search. But now with vector search and embeddings being natively available with the database, it's easier for us to get access to generative AI and advanced searches. So that is exactly why we're using vector search. So now that we have understood what we're doing and why we're doing, let's move on to step number 7, which is actually generating some insights using the remote models we created so far. Now there is a create table step here. I would encourage you to do this at your own time if you want to create a table and insert the conversions or insert the summarizations. But I don't want to do this because sometimes with very limited credits that we have, like $1 or $5, it is a lot of for Spanner, given that it's mainly known for its asset properties. It's a transactional database. It's not analytical database, right? We don't want to try doing things in batch at the moment. So what I would do is I would do the workaround section, which is directly running the select query with instead of inserting it, right? So what I'm asking you to do right now is go to step 7 of the code lab, which says create generative insights from patent abstracts, and scroll down until you see workaround section. Copy the select query that has ID content as Gemini response from ml.predict. So this is the construct we'll be using to call the Gemini model to work on the actual converting the abstract into summarized abstract step. All right, so just copy the select query, go to your Spanner Studio, just paste this query. All right, now what we are going to do, let me paste it in another tab so that you're able to appreciate the difference side by side. Run this query, don't change anything. Now what we're doing is, this is my prompt. My prompt is identify the areas of work or keywords from this abstract. That's all. All right, so it's running. Basically, when it's running behind the scenes, it's invoking the Gemini API. How it's invoking? Because you already created the model, remember? Gemini Pro model. So that is the model I'm invoking right here, right after the model keyword. And this is my prompt. Identify the areas of work and keywords from this abstract. And then the table is patents data. Limit 50, we only have 10 records, so it's okay. This limit 50 is moot. It's not useful right now. But anyway, so how will you interpret the result? So this is my result. Expand the first row and see, it's very beautifully extracted the areas of work and keywords from the abstract. Very nice to see that the first record in the table is related to display technology, material science, manufacturing, and optics. And these are the keywords and additional notes, which is brilliant. All right. So now we have used Gemini to summarize an already existing abstract. In fact, we have expanded the abstract. More than summarize, we have just given it a body and shape so that the next step, which is converting to embeddings, is meaningful. Right? Show of thumbs, how many of you appreciate it and how many of you are able to complete the step where you use Gemini right within the scope of SQL without writing additional code? Show of thumbs, please. Leads, can you activate
Reactions.
emojis? Yeah. Show of thumbs, how many of you? Perfect. Moving on to the next step. Oh, did I use a wrong spelling in my embeddings model? Let me see. Someone's pointing that out. If that is the case, it will fail. Let me just, is that right? Did I accidentally type a wrong spelling for my embeddings model?
Yeah, I think the project ID.
Okay, let me replace that. So what I'm going to do is I'm going to drop that model, which I created, drop model text embeddings. You don't have to do it. Please don't follow this step. If your project ID is accurate, just that's fine. Don't drop the model. I'm dropping it because apparently I've made a spelling mistake and I don't want that to be the case. So I'm going to create the model again, text embeddings, and my project ID is wrong. You don't have to do this step. This is just for me. Thanks for pointing that out. All right. So it's all done. Now go to the code lab. We have completed the first part of creating generative insights, which is reviewing the result of you. We use Gemini. We summarize the abstract. Now what we are going to do is observing insights. All right. So why we are doing this observing insights is right now we only converted, we are only displaying ID and Gemini response, but we want to see it in association with the whole table, right? So that is what this last query does, which is select title, abstract, Gemini response from patents data. And I'm joining that with this recent query that you ran in order to predict the model's response, right? So I'm just joining these two. So copy this. In step 7, the last workaround query that you're seeing, right? Right after workaround, you would have completed that step to see the ID and response. Now in observe insights section, why I'm not running the top section is that I did not create this table. If you remember, I skipped that creating table section because I didn't want to create table. I just wanted to show you and see the results, right? So I'm running the last query, which is joining the patents data with the Gemini model query. All right, so copy this query from here, go to your query editor and run this particular query. Now, all it does is it's not doing anything new. You already saw Gemini Pro result for the prompt that we wanted. This query is just joining the data along with its title and abstract from the base table, which is patents data. That's all it is doing, nothing else. We could have directly run this query in the first place. I just wanted to explain other things. So if you see, this is showing side by side what the title of the patent is, what the abstract is, and what the summarized abstract, the Gemini response of the abstract is. See, this is what the abstract looked like originally. This is what Gemini did to it by categorizing it into the formats that we wanted. All right, successfully completed observing the insights from Gemini. Show of thumbs, how many of you were able to successfully complete this?
Previous query still running.
It should have completed if you have only 10 records or something. It should not take.
No, I have inserted only 10 records, but it is still running.
Okay, please use the chat just
Yeah,
in
still
case, because if
still we are
anyone
not.
starts to unmute, it'll be overlapping. Okay, so if it is still running, what you can do is just try and convert one row and see what the response is. Or maybe you used up your billing account accidentally, you used up your credits accidentally. That could be a reason why it's running for long. But technically speaking, this should not take much time. It should be really quick for the, I only have $1. So if you, unless you accidentally used up the credits, it should be fine. Moving on. So this is the result screenshot that you will submit, the result of this query, what you see right here in the screenshot, right? Just one row, you'll have to submit the result for this code lab for session 1. Basically, this result screenshot that you're seeing for row, whatever row it is, similar to this, you will get a result like this, right? It should have the title, abstract, and Gemini response. That's it for one row. That's what you need to submit in the response. All right. So do that. If you see that the query is still running, there are multiple reasons. Your project ID might have been wrong. So it is still searching for the project ID, and the Gemini is trying to see which project it has to activate that API call to and all that. So just make sure all the other things are accurate, and then it should be completed. If not, just try for one record and you should be able to complete this step for the results. Moving on, this is the actual vector search part that we are going to run. Which is the generate embeddings part, and then do the vector search. So for this, again, I'm not going to create a table, nor I'm going to insert the embeddings there, but I'm just going to use a select query and observe the results and show it to you, and then just view the embeddings result in association with title and abstract. So what I'm going to do is I'm going to directly go to the last query in step 8, which is generate embeddings for the generated insights. That is my step 8. I'm going to go to the last query there, the select query. Just copy the whole query from there. I'll explain what the query does. So this is the query. Basically, it has the patents data table fields, title, abstract, and it calls patent embeddings. So what does patents embeddings contain? That field is actually using the model text embeddings, which we created initially. And that uses Gemini's response, which you see right here, it uses Gemini's response as its input and it converts that into text embeddings. And we are displaying this in a join with the paste table fields, which is title, abstract, and Gemini and the actual embeddings result. All right, so copy paste this and don't change anything, just run it. You should be able to get the results for maybe just limit it to one record if you want to do that, just to see the embeddings if you're not getting it. All right. All right, there we go. So this is exactly what you're seeing right here is important because this is what embeddings looks like. If you notice, it's an array of floats. And then as you can see right here, this is the abstract. And then we are printing the patents embeddings corresponding to the Gemini response version of the summary of the abstract, not this abstract itself, but the Gemini response. So where am I calling this? This is inside a nested query right here. As you can see, it is part of this query itself. All right. So this is what embeddings looks like. Now what I'm going to do is I'm going to append the user query also as part of a select query itself and then run this. Okay. Now I have it for 10 records. You can choose to insert all this into a table and then store it and then build your web application on top of it. That is what we have done in the AlloyDB code lab. It is there available for you. You can run it at your own time, but I'm going to walk through the AlloyDB steps after I complete this. Just one more step, and then we'll be done with this lab, and then we'll summarize this. All right, and then we'll move to. You will not be doing AlloyDB hands-on. I will just be telling you what extra we are going to do in that lab, and how you can associate that results from that particular lab, or even the one that you're doing in Spanner, how you can associate that into a web application or a serverless cloud function so that it can be consumed by your downstream applications. That's what we're going to discuss in that part. All right. So now that we have our embeddings resulted, all that we have left to do is to perform the actual vector search against user queries. So now I have 10 records only. So I have to pick and choose my user query that is somewhat related to some of these. All right, I can't be wild because what am I going to possibly do vector search with just 10 records, right? So for doing the last step, which is preparing for vector search or doing the actual vector search itself, go to step 9 of the code lab. So what we're going to do is we're going to use cosine similarity method to find the k nearest neighbors, similarity search. All right. In this case, the number of nearest neighbors that I want is probably, yeah, I have limited it to 2. Depends if you have larger data set. If you want more, if you want all of it, you probably don't limit the response, get all the nearest neighbors. In this case, I'm just limiting it to 2 because the data set itself is only 10. All right. So go to step 9 of the code lab, just go to prepare for vector search step. And if you scroll down, the first query, you should not be using it because we did not create all that intermediate tables that are required to run that query. So all we have to do is go to the workaround option because we directly ran the select SQL, the nested select queries. So that is what we are going to run right now. So copy this. I'll explain this in a bit. Copy the second select query from step 9 of the code lab, the last select query also. So now go here, just go to Spanner Studio, paste this query. I'll explain what it does. So what it does is it combines the result of everything that we did in the last step, and then it feeds that into a cosine distance method call. And what this distance does is it takes patents embeddings from the base embeddings that we already converted from the database, right? It compares that against the real-time embeddings conversion of user search data. In this case, my user search data is going to be what I enter. Right. So I have a default one in the code lab, which says a new natural language processing related machine learning model. Maybe I have an idea for it, but that's not what I'm going to do right now because our data is very limited. So I'm going to search for something that's related to, say, treadmill or exercise, workout using treadmill. Right. So let me just change this string to workout with treadmill or exercising with treadmill. I'll paste this query in the chat. With treadmill. Okay, I'll copy this and I'll paste this in the first line as well. Why do I have it 2 times? The first line is just for it to show that in the result. That's all. Typically, this you won't use, but I'm just putting it on top so that you will see the result. In the result, you'll see what users, what search text the user has used. That's all. All right. So I'll run this, and meanwhile, I'll copy this and give you this command in the meeting chat as well, while I explain what this query does. Oh, it's not copying the full thing. Sorry. So it's basically, don't worry about what you've copied from the chat, but basically go to step 9 of the code lab, go to the last query right before the observe results section, copy that query, paste it in your Spanner Studio, and make that one change. The single quote, within the single quote, you have a natural language related model as text. Replace that with exercising with treadmill in both places. And then just run this query. As you can see, I've got the cosine similarity results. Expand the first one. It's very accurate if you notice. It has brought out the one that's very related to it, right? Because of course I use similar words, so it was easy for it to find, but try it out with any context friendly words as well. Instead of exercising, use other words like workout with treadmill or something similar. It will still be able to get it. Now expand the second one. That this one says improved system to raise and lower a seat by simplified substantially parallelogram or non-parallelogram motion. This is somewhat similar to physical activity is what it thinks. Because there is no data with 10 records, it has to bring in 2 that are near, right? So that's why it's bringing in these 2 records. As you can see, the first one is closer, the second one is a little bit distant. That's why you see that score in cosine distance, whereas cosine similarity will have a different number. The larger the similarity score, the closer the neighbors are. In this case, it's cosine distance. So the larger the distance, the farther the... Wait a second, it's asking me to reload something. That's a different tab. Don't worry about it. Where are we? Oh no. Can somebody confirm if you're still hearing me?
Yes, ma'am, we can hear you.
Yes,
Okay,
ma'am.
thank you so much.
Hear you, ma'am.
Okay, thank you. All right, so as you can see right here, it is bringing in the best possible nearest neighbors from the available data set. So that is pretty much it for this particular code lab. So to explain this query, what I've done is I've nested base data with Gemini Pro model call, and I've converted the abstract into summarized abstract. And then I've called the text embeddings model, converted the summarized abstract into embeddings, and then passed that embeddings to compare against real-time user search, which is working out with treadmill or something similar. Let's try out with workout with treadmill and see what it does. All right, so this is exactly what we have done in this particular code lab. As you can see, it is bringing out the nearest neighbors from the data that is stored against the user search query within the scope of the database itself. So if you have a data analyst team working on this and they know to use queries, then that is exactly what you accomplish with this kind of a scenario or implementation. Oh my goodness, sorry about this. All right. So as you can see, I replaced the exercising word with workout, and it is still able to bring out the similar neighbors. Exercise treadmill is disclosed, front rail, so on and so forth. And then there is the adjustable seat and support system is coming up anyway. So clearly it works. It has given us the distance score as well. So that's pretty much it. How many of you were able to successfully complete this step? Show of thumbs, please. Leads, can you activate the emojis? Thank you. So cosine distance is a way of invoking the relationship between vectors. It is an already existing concept. Cosine distance is not new in the world of generative AI, but incorporating that as part of your data and converting it within the scope of your data is new with generative AI. But cosine distance is a probability theory. It's a probability concept from a while ago. So cosine distance is something that will let you calculate the distance or similarity between text or any form of data that the user searches against the database, right? So that is what we're using it for. There are multiple methods. There is also Euclidean distance instead of cosine similarity if you want to use. All right. Now, how many of you were able to create it? I see thumbs up, a lot of thumbs up and a few thumbs down as well. So I hope you're I mean, if you're in the process of doing it hands-on, don't worry about it. You have the code lab, you can complete it at your own time. There's nothing um, stopping you from completing the code lab at your own time. You will have a copy of this recording as well in your inbox once the recording is processed. All right. Now, one thing I want to leave you with is if you so two things I want to leave you with. One is submission of results. So for submission of results, it's enough to submit the result of step 7, the last. I think that's what the result submission app asks of you as well. It is there in the session description. So if you go to the session description also, you can get that information. Season 6, session 1, step 7. It says what exactly you need to submit. It is the screenshot of this result only. If you have a different record, that's totally fine, but it has to have the 3 fields: title, abstract, and Gemini response. Use the app in the description of the session, which says Gen 3-UX, so that particular link. Use that link to submit your screenshots of the results. I'll copy paste the link here as well, but you can find all this information in the website. All right. Let me pin that as well. So just in case at your own time. Use Gemini 1.0 Pro because the inherent native database support, I don't know if it is made available for 1.5 Pro yet, but you can always refer the documentation. At the time I created the lab, it was only available until 1.0 Pro. It was available for other models before that. So in case some of you are not able to access this because or do the prediction because your credits ran out or something of that sort, try it out later. Just run for one query and see the response. You will be able to run it. If you don't have credits, you have 2 links anyway. Try the other billing account and then you will be able to get this thing completed. For one record, definitely it will work. Because the billing account is of minimal credits, it will cause issues for some people, but you will be able to run it for one record at least. If the one of your billing accounts is used up completely, use the other one. That's why there is always a backup link. All right. For signing up to result validation, it is simple. Just create a lab code. The link to the same thing has a link to link with instructions. So go to Code Vipassana landing page. Here you will see, scroll down, not the session page, but the landing page itself. Scroll down, you will see result submission and validation section. In there, you have video instructions on how to submit the result. So use that link. Use that video to submit your result if you have questions. Lab code is any code, unique code that you enter for yourself. That's all. If you have lab code from season 5, you can use the same lab code so that you'll remember it, right? So it's easy to remember. So use that. If you want to create a new lab code, please feel free to create a new lab code as well. That's totally fine. It's nothing but a code that you create to uniquely identify yourself. That's all. So one last thing that I want to leave you with is the AlloyDB code lab. We did not go through the entire code lab, but I'm going to walk you through just at a high level for 2 minutes, and then we'll wind up the session. So with AlloyDB, the main difference here is the use case is same. What we're doing differently here is instead of using the spanner database, we are going to use AlloyDB database. So that's the main difference. Let me open that lab quickly. Okay. Instead of using spanner, we'll use AlloyDB. Go to step 5. If you see right there, you will see the embeddings, how we've tested embeddings in AlloyDB. It's pretty much the same thing. The only difference there is that in addition to generating vector search, we have taken this application to web. So how have we taken the application to web? We have created a cloud functions application. How to create it? The instructions are there in step 7 of the second code lab. You don't have to do this. This is for self-paced study. If you want to take your application to web and production, you can use this method. All right, go to step 7 of the code lab, AlloyDB code lab, and see how to create a cloud functions application. Create the cloud functions application, copy the code from the repository, which is linked here in step 0.4 of step 7 of the code lab, and replace the credentials with yours and write the query. Exactly what you wrote right now, the vector search query, it's slightly different. The syntax is different for AlloyDB. So you will see that the query is invoked from within a Java cloud functions. All right. And then you will deploy the cloud function and call the cloud function from web, and you will be able to see the result like this on the web. So that is the only difference between this and that lab, except that AlloyDB is super fast. You will be able to create vector search there. And you will be able to test for more records in AlloyDB as compared to Spanner because of the purpose of each database. That's why. All right. So that's about it. Don't get disheartened if you're not able to complete the step. You can complete it at your own time right after the session. Show of thumbs, how many of you were able to follow what we did so far? I'll just stop the recording while you show thumbs, please. So if Vertex AI calls quotas exceeded, that is a possibility, quota exceeded error, then run just for one line. If that is also causing an issue, use the other billing account.